Students, a very good afternoon to all of you. Yesterday we have discussed about the lock variable, that is a synchronization mechanism. Now today we will study about the turn variable mechanism of synchronization. Now the turn variable is also known as a strict alternative approach, and it is a software mechanism implemented at user mode. Now it is a busy waiting solution which can be implemented only for two processes. In this approach, a turn variable is used as a lock. Now let us take two processes. One is PI and another one is PJ. So for process PI, while turn is not equal to I, then we get a critical section, and we have put it turn as a lock variable to J, and just like for process PJ, while turn is not equal to J, critical section, turn equal to I. So this is the lock mechanism for the process PI and PJ. Now the actual problem of the lock variable approach was the fact that the process was entering in the critical section only when the lock variable is 1, and more than one process could see the lock variable as 1 at the same time. So in this, the mutex problem was not guaranteed there. So we have used a turn variable approach. In this, we get lock on two processes at the same time. So now now in the turn variable approach, the four conditions that we have must for must for critical section. One is mutual exclusion. In short form, we can say that mutex. Another one is progress. Another one is bounded waiting. Another one is portability. So in this turn variable approach, we get mutex, we get bounded waiting, we get portability, but we didn't get the progress of the process from one state to another state. Now let us look towards mutex. The turn variable approach provides mutual exclusion in every case. This procedure works only for two processes at a time. The pseudocode or the logic is different for both the processes. In this, the process will only enter when it sees that the turn variable is equal to its PID, that is process ID. Otherwise, no process can enter in the critical section reason. Now progress. Now progress is not guaranteed in this mechanism. Suppose we have two processes Pi and Pj. If P1 doesn't want to enter into critical section, on its turn, then Pj got blocked for infinite times. Pj has to wait so long as its turn, since the turn variable will remain 0 until Pi assign it to j. It means process has to wait for its turn whether the process is entering in critical section or not. Now next is portability. Now this solution provides portability. It is a pure software mechanism implemented at user mode and does not need any special instructions from an operating system. So this is the turn variable mechanism. Hope you have understood this one. Thank you very much.